They aren't using silver anymore. They're entering it, and they're doing it at scale, not in grams, but in metric tons inside something you can't open, can't melt, can't reclaim. Solar panels. Specifically, TOPCon cells. Specifically, under glass. 87% of all new industrial silver demand in 2026 flows there, not into wires, not into contacts, not into solder. Into sealed, static, silent layers fused to silicon and buried beneath tempered glass. That's not demand, that's deposition. $22 billion in IRA Phase 2 funding didn't just subsidize solar. It subsidized entombment. Think about that number. $22 billion not for research, not for R&D, for manufacturing, for building factories that print silver paste onto wafers, bake it at 180 degrees Celsius, laminate it under 4 millimeters of tempered glass, and ship it to rooftops across Texas, Arizona, and Ohio. Then bolt it down. Then walk away. Jewelry melts. Electronics shred. Solar panels? Get glued, sealed, shipped, installed, forgotten. Unlike every other major silver application in history, solar silver isn't consumed. It's entombed asterisk, bonded to silicon, dispersed across nanoscale grids, then locked behind glass designed to last 30 years, then landfilled. There is no uninstall button, no recall, no retrieval protocol. What happens when the world's most conductive metal stops flowing and starts fossilizing? Pause. That stillness? That's not calm. That's absence. That's 12 million ounces gone last quarter. Not sold, not stored, gone. Shanghai Futures Exchange Vault data confirms it. 0 tons of recycled solar silver entered global inventory since January 2026. The first time in recorded history in 5,000 years that a major silver application has contributed nothing back to the supply chain. This isn't consumption, it's deposition, and deposition doesn't reverse. Policy didn't choose silver. Physics forbade anything else. Chapter 1 showed you where silver is going: buried under glass, sealed in solar panels, vanishing from vaults. This chapter answers the question no one dares ask aloud. What if we tried to stop it? Not with tariffs, not with subsidies, not with lobbying. What if we tried to replace silver in TOPCon cells with something cheaper? Something more abundant? Copper, aluminum, graphene. 3 materials, 1 lab, 1 verdict. NREL, the National Renewable Energy Lab, ran the test. Not once, not twice. Under identical sintering conditions, 180 degrees Celsius. Nano-thin layers. Daily thermal cycling. Real-world stress. Here's what happened. Copper oxidized instantly. Not rust. Not surface discoloration. Atomic disintegration. Within 90 seconds of heating, copper atoms bonded with oxygen, bloated the lattice, and cracked the conductive path. Electron flow collapsed. Cell efficiency dropped 47% in under 72 hours. Aluminum melted, not figuratively, literally. Its melting point is 660 degrees Celsius, but at nanoscale thickness, under thermal cycling, it liquefied at 180 degrees Celsius. Not uniformly, in patches, creating micro-shorts, hot spots, and within 11 days catastrophic delamination from the silicon base. Graphene? It held shape, looked perfect under microscope, until day 17, then delamination, not at edges, at the asterisk center. Because graphene's van der Waals bonds can't withstand the coefficient mismatch between silicon and glass. It peeled silently, invisibly, until the cell lost 32% of its output. All 3 failed. Not slowly, not expensively, fundamentally. Because silver's electron mobility at nanoscale is 2.3 times higher than copper's. That's not a statistic. That's the difference between electrons flowing smoothly and electrons scattering, generating heat, fracturing crystal lattices, killing the cell. TOPCon cells operate at the quantum edge, where conduction isn't about bulk metal, but about electron coherence across sub-15 micron grids. Try wiring your brain with copper wire. It works, until it doesn't. Same principle. Silver doesn't just conduct better. It stabilizes. Its atomic lattice absorbs thermal stress. Its electrons move without scattering. Its surface resists oxidation asterisk at operating temperature. You cannot engineer around that. You cannot subsidize past it. You cannot scale past it. This isn't a cost barrier. It's a material ceiling, and that ceiling isn't theoretical. It's baked into every TOPCon panel installed since Q1 2026. Policy opened the door, physics welded it shut, and silver holds the key. They told you recycling would save silver. They showed you infographics of circular economies. They quoted 82% recovery from jewelry, 35% from electronics. But solar panels? Zero. Not low, not delayed, zero. Shanghai Futures Exchange Vault data, the most authoritative global ledger for physical silver, shows 0 tons of recycled solar silver entering inventory since January 2026. That's not a gap, that's a void. The first time in 5,000 years since the Lydians minted the first silver coin that a major industrial application contributed nothing back to the supply chain. So let's dismantle the mirage. Not gently, brutally. Only 1.2% of solar-grade silver is economically recoverable. Think about that number. Jewelry, 82%. Electronics, 35%. Solar panels, 1.2%. That's not a slowdown, that's a hard stop. Why? 3 reasons, none of them political. All of them physical. First, panels aren't soldered. They're glued. Epoxy. Lamination. Tempered glass fused to silicon. There is no unplug and recycle step. To reach the silver, you must destroy the panel, then separate. Glass, aluminum frame, EVA encapsulant, silicon wafer, and backsheet by hand, by acid, by machine. It takes 17 steps. And at step 12, you hit the silver not as wire or foil. As nano-dispersed paste asterisk, 12-micron thin grids, baked into silicon, bonded at the atomic level. Second, recovery isn't extraction. It's asterisk acid leaching, followed by asterisk electro-refining, a process that costs $42 per ounce. Meanwhile, mined silver costs $28 per ounce. You don't recycle at a 50% loss. You bury it deeper. Third, there is no infrastructure. No collection network. No sorting hubs. No refineries licensed for solar silver because the yield is too low, the contamination too high, the margin too thin. The DOE's January 2026 report didn't call it challenging. It called it economically non-viable without $120 per oz silver, and even then, only at scale that doesn't exist. So what happens to the other 98.8%? It goes to landfills, or gets crushed into concrete aggregate, or sits on rooftops inert, invisible, irretrievable for 30 years. Then gets bulldozed. Pause for 2 seconds. That silence? That's the sound of 12 million ounces of silver gone last quarter. Not sold, not stored, gone, not missing, not delayed, erased, from vaults, from balance sheets, from the very idea of supply. You think recycling is coming? Look at the vaults. Look at the math. Look at the glue. This isn't a bottleneck. It's a terminus. And the last train left with no return schedule. Gold circulates. Silver fossilizes. That's not poetic license. It's the first line of silver's new taxonomy. Chapter 1 showed you entombment. Chapter 2 proved physics locked the door. Chapter 3 confirmed the vaults went silent. Now this is what that silence means. Not for price, not for miners, but for money itself. Because silver is exiting the precious metal class, not because it's less rare, less shiny, less historically monetary, but because its function has been surgically removed. Gold's monetary role thrives on asterisk motion asterisk. Central banks buy it, hold it, lend it, swap it, collateralize debt with it. Its value isn't just in scarcity, it's in asterisk turnover. In trust that it will move again. Silver's new role? Strategic embedding. Governments don't want it back. They subsidize its permanent removal via $22 billion in IRA Phase 2 funding to lock electrons into solar cells, not liquidity into balance sheets. That's not demand. That's declassification. Fred data shows M2 velocity collapsing, a sign of slowing economic circulation. But silver's velocity, measured by actual turnover in LBMA vaults, has dropped asterisk 63% since 2021. Faster than copper, faster than palladium, faster than any commodity tracked in modern records. Why? Because vaults aren't holding silver. They're holding paper promises while physical silver flows irreversibly into glass. Can something be monetary if no central bank can lend it? If no repo desk can pledge it? If no sovereign wealth fund can collateralize it because it's not in vaults, but under Arizona desert sun. This isn't a price story. It's a classification crisis. Precious metals have always balanced two roles: industrial utility and monetary function. Gold. Yes. Platinum. Yes. Palladium. Yes. Silver used too. Jewelry, electronics, coins, reserves. Now, its industrial function has eaten its monetary one. You cannot lend nano-dispersed silver paste fused to silicon beneath tempered glass. You cannot repo a rooftop in Texas. You cannot collateralize landfill aggregate. So silver isn't becoming scarce. It's becoming geologic. Not metaphorically. Literally. It takes 10 million years to form silver ore. We're burying 12 million ounces per quarter faster than geology can replenish, faster than markets can replace, faster than policy can redirect. Let that sink in. Not as investors, as classifiers. This isn't a supply shock. It's a phase change. Silver isn't becoming scarce, it's becoming geologic. And geology doesn't reverse on a quarterly earnings call.